Okay, so this is the second part of the making things, Revit to Real tutorial set. And so I'm going very old school with the screencast today using a camcorder pointed at a screen. And that's primarily because we're going to be looking both at Rep-G and connecting it to the TOM to do the print of this roof from the end of the first tutorial in terms of preparing a model from Revit and moving it into Rep-G. But I also wanted to show the TOM in operation and look at some of the specific things that we're doing with it and getting the machine itself prepped to do the print. So I've got the piece of the roof organized and in place, and again, the thing about this roof in particular is that it's a three-dimensional curve. It's curving on both the X, Y, and Z axis. It has some tricky little structural elements, and again, this was half of the roof, so I sliced it sort of down the middle, and I have the opportunity to print two halves of this roof and get them to come together, glue them together down the center. I'm printing an ABS plastic, so a model glue works great to glue those things together. And the ABS plastic, if you use a really fine sandpaper, not a 60 or something like that, but something into the upper 100s in sandpaper, it will sand down to a really excellent finish as well. So the process in terms of working with Rep-G and pushing a file to the TOM is I've got the file ready. I'm on the Mac that we have hooked to our TOM right now. The first thing that I always do is I go to the control panel, and there is sort of a routine to do this, but I like to go ahead and preheat the machine manually. And so I come to the step extruder MK6 target temperature, which is 225 degrees Celsius, and then I set the platform target, so we're running a heated base plate or an HPB base plate, and I set that to 110. That ideally ensures that the plastic is going to stick fairly well to the base plate as it starts to print. And 225, at least for us, has been a really good melting temperature for the ABS plastic. So those are the two settings that I like to do, and usually it takes the machine maybe about 10 minutes to get to temperature. The next thing that I'll usually do is, once it is to temperature, I'll do a test run of some of the plastic, just make sure it's extruding correctly before I start a print. So I'll do an extrude duration of about 5 seconds and hit forward. And I'm not going to shift over to the TOM right now, but the idea is that I get a good string of plastic that comes out before I do anything else, before I invest the time in building a print, just to make sure that the extrusion is happening smoothly. So I'm going to go ahead and close that up. Or actually, I'm going to leave it open and just move it to the background. So the next thing that I want to do is go ahead and generate the G-code. So I'm going to click Generate G-code, and I want to point out a couple of things. First of all, this is a really thin piece. Let me close this back up and rotate to a different view. It's a really thin piece. That's going to have trouble standing up on its own. So one of the things that I'm going to do is print this on a raft. And so a raft basically is going to build a custom layer around the base of the object. And the problem that we had early on with building rafts is that it didn't build a raft. I mean, it built an entire boat. It was this 1/4-inch thick layer of plastic. And it took us a while to find this. I had read someplace online that the raft should be like pulling off a piece of Velcro. It shouldn't be something that you have to take a hammer and chisel to. So eventually, after digging through the settings, we were able to find this. Underneath G-code, you can go to Edit Slicing Profiles, and we're going to select the MK6 profile and Edit. And that's going to pull up SkeenForge settings. And on the SkeenForge settings, I've already edited the raft settings, so I've got that selected. And what I did was I really decreased the values overall of what the raft was, decreasing the density of the plastic that's printed out and decreasing the number of layers. And all that worked really well to create a raft that sort of peels off, again, not perfectly, but much, much better than the default raft that comes with Rep-G. I'm a little bit worried that those settings are probably not as clear as they should be using the old school screencast here. So if you need those settings, don't hesitate to drop me a note, dbeach01@drury.edu, or just make a comment on the YouTube site or the Architect's Digital Design Guide site, and I can get those settings over to you for a raft. So I'm going to go ahead and close that up and click Done here. And the next step is clicking on Generate G-code. I've got this selected, the use raft selected. If that's off, it's just going to start printing the bottom line of this edge. If it is on, what it's going to do is print the raft first and then print the object. Next, those are the settings that I'm using. So I'm not using any infill at all. This is a really thin object. And if I build with an infill, essentially it's going to try and move the object back and forth to infill with some percentage of plastic. What we found is on thinner objects, which a lot of architecture is, we're printing walls and roofs and things like that, that the outer edge of plastic, only printing the outer edge of plastic, gets a much smoother, much cleaner print. It doesn't sort of shake the model to death because, you know, it's the base, this portion, the model is going to be moving in the X and Y direction on the TOM, and the print head is going to be moving in the Z direction. So as it's printing this object, it's kind of shaking it back and forth. You'll see that in the video coming up. If I can minimize that shaking back and forth, I actually get a much better print. I slow down the feed rate pretty significantly. I usually run that at about a 25. I'm more interested in accuracy than speed. The layer height is 0.3 millimeters, and that's largely what we found works well with 3 millimeter plastic. So I've got 2.94 millimeter ABS plastic running through a 0.5 millimeter nozzle with a 10.58 millimeter gear, and those in particular are the MK6 with a 0.5 millimeter nozzle defaults. What I have changed from those defaults are the infill and the feed rate. Everything else is set to the defaults. It takes about 5 or 10 minutes to generate this G code on this particular computer, so I'm going to spare you that time, and what I'm just going to do is go ahead and hit cancel. So I've already run the G code. We can take a look at the code that is generated. The first thing to note, hopefully you can see it on screen, I always double check that the build platform is set to 110 on the temperature, and that the print head is at 225. Those are two things that on occasion I come back and adjust in the code and resave the code. From there, what we do with that G code tab open, I go ahead and hit the build. So the first thing that the TOM is going to do is it is going to zero itself out. And this process takes a couple of minutes. It's going to zero itself out, and then it is going to hold that position for a while the TOM is verifying that everything is at temperature. So right now I'm reading that the step extruder is running at 223 degrees Celsius, so it's going to take it a few minutes to get it up to temperature. I'm going to remove this little scrap piece of plastic here. And what it's going to do just before it prints is it's going to send out about 10 seconds, 5 seconds worth of plastic, worth of ABS plastic, which can be a little bit of a mess, but it's a pretty important step. And it's an important step because that's your one chance to sort of ensure that the extrusion is working correctly before the print starts. If something goes wrong with the extrusion process, what you end up with is a large pile of spaghetti at some point in time, which is not what we want. So essentially what's happening is we have a filament right here that's being forced through a gear system. It is being melted, and it is laying a line of plastic that is approximately 0.3 millimeters in height at each level. And then as the platform here moves in the X and Y direction, the print head is going to constantly step up at that 0.3 millimeter mark vertically or on the Z direction each time. So the tensioning with this little piece right here is really critical because that is what sets a constant feed rate on this particular gear shaft. So as I get this chunk of plastic here, I always want to make sure that that's a good quality print, that the plastic is coming out smoothly, and I always want to get it out of the way before the print starts. And so the clicking is a pretty good indication that I've got the tension a little bit too high, but I'm going to go ahead and let it run, and hopefully everything works out okay. So this should begin by printing out a perimeter line for me. And that perimeter line basically defines the overall base or the print area. And this is always a convenient step because I have definitely seen this project or this process go off of the edge on the printing, which is kind of a nightmare. But this begins to set up the overall print and print process. I know that it's going to fit, so right now it's printing the raft. And once that portion of the process is done, I'll turn the camera back on. I'm going to spare you guys watching this forever and a day, but we'll get the raft printed and then we'll start taking a look at it again as the actual roof piece begins to prep. So the machine is finishing up the last little corner of the build, and it's moving in a really short distance, so the tom is slowed to an absolute crawl, but it's finishing up this last little corner at the top edge. And you can see, you know, right away, it's definitely not a perfect print. There are definitely some things to fix, some things that we could tweak. And if I was working on a whole row of roofs like this, it's definitely things that I would want to pay attention to, figure out how I could get the settings working a little bit better. In particular, you'll notice, I don't know how well the resolution will show up on this, but the print head is actually getting down into the wall itself a little bit that it's printing. And that causes a little bit of a squish with the plastic, and things get just a little bit out of line. So, you know, modifying the print speed and the layer height are two things that could probably begin working to begin to remedy that a little bit. But the piece is done. The other thing that's interesting that happened in this particular build is, you know, we had the structure built in place to print with the wall, and it unfortunately didn't build any of the structural beams as it came together. My guess is that they're too narrow, and so the MakerBot and Replicator G, the software that interfaces and does the slicing, if they were too small, that perhaps they were ignored as something that were too small to print. It's sort of underneath the resolution. So the next thing that I would do in a case like that is I had modeled those as walls inside of Revit, so I could go in and edit the wall type, quickly exaggerate their width that might not be to scale accurate anymore. You know, if it was a 6-inch wide beam and I'm going to turn it, let's say, into a 12-inch wide beam, it might not be to scale accurate anymore, but it would get the design idea across. And that would sort of be my next step to take a look at it. So let's see if I can carefully pop this print off without warping it too much. And you can start to see the quality of the print. You know, this is a piece, again, that is warping in multiple directions. It's both sort of bending out and warping around. You can see in particular, you know, where there is some waviness to the plastic right there along the edges, that it's definitely something that we would need to tweak the print settings to get a really good, solid final print for. But it's definitely workable. And if this was if I was only going to print one of these, I would be perfectly happy with that, because I know I can take sandpaper to that very, very quickly and get those edges sort of polished off and smoothed out without any effort. On the squishing of the plastic, you can kind of see the inconsistency of the corner right there, and that's a bigger concern of mine, and that has to do primarily with the layer height, where the print head is actually getting too far into the printing. And that's something, again, could probably adjust if I was going to print 2 or 3 more of these, or if I had a whole series of these that I wanted to print out. But again, for that one, probably I can knock those edges off pretty quickly with sandpaper and get it pretty close to exactly what I'm looking for. So, you know, as sort of a first attempt at printing, I'm pretty happy with it. And if this was going to come together with my model, I feel like I could probably turn that into a finished piece relatively quickly. Some other things, you know, going over the top of them with a little bit of plaster or with a thicker paint also helps fill in those voids and helps finish the pieces off really well. As well as, you know, I've seen several experiments done with some acetone vapor and some more, well, let's call them what it is, a little bit more frightening experiments, but with some pretty interesting success in terms of turning a fairly rough piece into something really well finished. So the last thing, ripping the raft off, which I'm going to do off camera for the sake of sort of the violence of it. But the raft should come off pretty easily. So you can see I'm just pulling off in chunks. Just kind of like that. But usually what we're left with is a little bit of an edge to sand off, is all. But that should come off, so I've got a little bit of a piece to sand off right there. But if the raft isn't coming off that easily, then definitely want to go back in and tweak the settings. And that is the introduction to moving things from Revit to Real.